in fact, generally for binary sources, this type of source code will not produce a very good result. So what we really want is we want to create sources that have very high entropy, because if h of x is large, this 1-bit penalty is comparably small. So this kind of a source is not a very good candidate for source coding. How could we take this source and somehow rearrange it to get a source with high entropy? Any ideas?
Say it again.
Okay, what I want is I want h of x to be big, because otherwise this 1-bit penalty will be comparably large. So, I mean, here we see that h of x is approximately 0.07. What is it? It's like, yeah, it's about 0.07. So 1 compared to 0.07 is enormous. If I instead had h of x is equal to 700, let's say, then 700 compared to 701 isn't very much. So now I'm relatively close to entropy. So how would I rearrange my source so that h of x is large?
You must introduce some uncertainty.
That's an idea.
But can you introduce auxiliary things like which don't exist in the original set? Just to increase the complexity of.
To increase the complexity. So you're on the right track. Basically what we want to do is create things with lower probability, because that will increase the entropy.
To create some chaos in the coding so that you have additional possibilities with other probabilities, and it's not one and or the other.
Right, so that's, it's on the right track. So what we want is we want to have objects with smaller probability, because smaller probability in general, because that will lead to higher entropy. What we don't want is we don't want a non-deterministic system. So what instead I propose is the following. So the outcomes of these are xi, and these are, we end up with a vector of these. I mean, this is a repeated experiment. Where these are A, B, A, so on, or A, B, B, so on and so on. What I propose to do is I propose to group them together. Something like this. So I'll form extensions of the source.
That means you'll be coding the groupings of source, the message symbols.
That's exactly right. So, for instance, the first extension of this source is over x squared, and the possible letters are AA, AB, BA, and BB. We still won't get a very good result there. We can get the nth extension of the source, which will be to group x1, x2, x3 up to xn together as one source letter, and then xn plus 1, xn plus 2, xn plus 3, and so on up to x2n as the second source letter, and then x2n plus 1, and so on and so on and so on up to x3n, third source letter, and so on. It turns out that the larger n gets, the closer you will get to entropy. For the following reason. So let's call this extended source. This extended source, let's call x bar. So this first letter, let's call it x bar 1. Second letter, let's call this x bar 2, x bar 3, and so on. So basically what I'm doing is I'm taking vectors of x and just calling them x bar. So clearly there's a probability distribution over these. What is the entropy of x bar? It's the entropy of x1, x2, x3, and so on up to xn. Now, all along we've implicitly assumed that the xi's, that the source letters are IID. What does IID stand for again? Independent and identically distributed. So they're these letters are independent. So how does the joint entropy break up? This is from the first class. It's actually the sum. The
entropy.
The entropy breaks up as a sum when they're independent. But their IID, the other I, is identical. So therefore all of these entropies are the same because they're identically distributed. So this is equal to n h of x. Now, if I now encode x bar, I still have this relation. That's still valid, even if my code is over x bar. But now I can substitute this for h of x bar. So, goal achieved. I can make n as large as I want. So I can make this entropy, the left and the right boundaries of entropy, I can make them as large as I want by selecting an enormous value of n. And so therefore this penalty of 1 bit per source letter dwindles. And in fact, if I want to express this in terms of the original coding scheme, I can divide through by n. Let's call this L bar for the extended code. I can say h of x less than or equal to 1 over n L bar of c, less than or equal to h of x plus 1 over n. So per source letter, I can basically make this penalty go to 0. So the moral of the story is use extensions. Don't just encode on a per letter basis, but use extensions. Okay, there's still one loose end to tie up. Any questions on this? There's still a loose end to tie up.